children, and welcome to your channel Sharda Educare. And in this video we are continuing with the examples exercise from 1.3 exercise of similarity chapter. In earlier video, that is #09, we have solved example from the textbook, and in this video we will be solving the exercise 1.3. Let's begin, children. The first sum you can see on the screen. There is a triangle ABC and there is a triangle DEC. ABC, this angle is in triangle ABC, angle B is given, angle B is given 75 degree, and in small triangle DEC, angle D is given 75 degree. Okay. So on big triangle there is a small triangle. Let me draw these two triangles separately. I am drawing this bigger triangle here. Triangle A, B and C. Angle B is given how much? It is given 75 degree. Okay. And this is the small triangle. I will pick it up and keep it separately. The small triangle is here. This one. C, E and D. D is how much? D is also given 75 degree. So when I pick up this triangle and keep on it, it will be looking like this. The figure would be like this. So when I pick this up and keep over here, what happens? This angle C will completely overlap angle C. See. Yes or no? Angle C is completely covering angle C. When I lift this small triangle and pick on this, keep on this. When I pick up this triangle and keep on it, it will be entirely covering. This angle will be entirely covering, and therefore see, this line and this line, there is no, you cannot see any part of bigger triangle this side. It is entirely covering. So this angle, this C angle is falling on angle C. So angle C is equal to angle C, children? Yes? We can say yes. So we can say angle C is equal to angle C, and reason for this is common angle. Common means they completely overlap each other. What else is equal in this two triangle? See. Angle B is 75 degree and angle D is also 75 degree. Angle B is 75 degree and angle D is 75 degree. So we can say angle B is equal to angle D is equal to 75 degree, and it is given. So we can easily say that triangle ABC is similar to triangle. Now ABC is similar to which triangle? EDC. Why I am writing E first, D, then C? See, here C is last and C is last. Both C angles are equal to one another. And then B is equal to D, B is second and D is second. So the first, so they must correspond, equal angle must correspond to each other. Here angle C is corresponding to angle C, angle B is corresponding to angle D, and B and D are equal. Therefore these two triangles are similar. While writing you have to take care, while writing this way only you should write angle test. by angle and angle test, these two triangles are similar. So write the similarity of these two triangles by a proper one-to-one correspondence. This is known as correspondence. Angle C is equal to angle C, angle B is equal to angle D, and only two angles are enough to prove any two triangle similar. Now this is the question which is asked in your book, but we will also write the corresponding sides. That is going to be helpful to you. AB, we can write AB, if two triangles are similar, AB upon ED, which is equal to BC upon DC, BC upon DC, and AC upon EC is equal to AC upon EC. Corresponding sides of similar triangle. Now move to the second question. There are two triangles which you can see, children, clearly. This is triangle PQR and triangle LMN. Are these triangles similar? And if they are similar, by which test they are similar? We can see only the sides are there. There are no angles given. So let us see the corresponding sides. PQ is corresponding to LM. Let's find out the ratio of PQ upon LM. How much is PQ? 6. And how much is LM? 3. So what we are getting? 3 ones are 3 twos are. So we are getting 2 upon 1. This is our first statement. Then second, QR corresponds to MN. So we will write QR upon MN. QR is how much? 8 upon MN is 4. So 4 ones are 4 twos are. So again we are getting 2 upon 1. This is our second statement. Now let us go for PR and LN. PR upon LN. PR is how much? 10 and LN is how much? 5. So 5 ones are 5 twos are. We are getting 2 upon 1, third statement. Now looking at these three statements, this is the first one, this is second one, and this is third one. All these three if you compare, you come to know that, or you can come to the conclusion that PQ upon LM is equal to, because each ratio is equal to 2 upon 1, QR upon MN, which is equal to PR upon LN. All the ratio are equal to one another, and from where did we get? We got it from first, second and third. So from first, second and third, we can say all these three ratios are equal. If all the three corresponding ratios are equal, then the triangles are similar. See, in the previous question what we did, when two triangles we got similar, we wrote the corresponding ratios equal, corresponding sides ratio equal we wrote. Now if corresponding sides ratio are equal, then the triangle will be similar. So we can say therefore triangle PQR is similar to triangle LMN by side test. You can pause the video, children, and you can solve the sum. Question number 3, we can see here on the figure on the board, there are two triangles. There is one triangle PRQ. PR is given 4 and QR is given 6. and there is another triangle ACB in which AC is given 8 and BC is given X. So, two poles of height 8 meter and 4 meter are perpendicular. This is 4 meter height and this is 8 meter height. They are perpendicular, and this is the shadow which is falling. QR is the shadow of PR. See, suppose if any pole is there here and light will be flashed from here, if light will be flashing on this pole, there will be shadow forming this side. See, when sun is this side, your shadow forms on the road in front of you, and if the sun is facing you, your shadow will be behind. So, like this, that means if the shadow is this side, the sun or the light is falling from this side. So, QR is the 6, means shadow height is 6, length of the shadow is 6, and here length of the shadow we want to find out. What will be the length of shadow? Okay. Now, as this is the pole and this is also pole, it is going to be perpendicular to the ground. So, definitely two right angle triangle will be similar. So, we can say triangle PRQ is similar to triangle ACB. Triangle ACB. It is given because they are perpendicular. PR is perpendicular to QR and AC is perpendicular to BC, and therefore they are similar. Okay. Now, if those two triangles are similar, we can use corresponding side ratio. We can easily use corresponding side ratio. In the earlier question also we saw, we will be taking PR upon AC. So, PR upon AC is equal to RQ upon CB, RQ upon CB, which is equal to PQ upon AB, corresponding sides of similar triangle. Once you have taken this, look for the values to place. What is PR here? PR is 4. So, I will be placing the value of PR 4 upon AC is how much? AC is 8 equal to QR. This is QR. QR is how much? 6 upon CB. CB is how much? X. So, we need to take only this two ratio to get the value of X. There is no need to struggle for this because we want to find out the length of the shadow formed by the pole AC. Now, I am taking it here, 4 upon 8 is equal to 6 upon X. Now, see children, it is very, very important to know for the children, X will move up and 4 will come down in place of X. Okay, I am moving X here. This is what children do not know. 6 is there only X I shifted. So, in place of X what will come? 4 will come. And this 8 which is down will go where with 6 into 8. This 8 will come here. Okay. So, what are we getting? 4 1s are 4 2s are 2 6 are 12. So, X is equal to 12. So, length of the shadow formed by the pole AC is equal to 12 unit. It is not mentioned about meter. It is 12 meter. So, at the end you need to write down, therefore, length of shadow of AC is equal to 12 meter. You can pause children and you can solve the sum. Question number 4th of practice set 1.3. Triangle ABC, where AP is perpendicular to BC, and in triangle ABC, AP is perpendicular to BC, and BQ is perpendicular to AC. Yes, that means it is 90 degree here. Then we have to prove that triangle CPA, triangle CPA is similar to triangle CQB, is similar to triangle CQB. Clear? So again, these are two triangles which are overlapping one another. If I happen to draw them separately, for example, I am drawing CQB here. See, my triangle CQB is here. This is CQB, and CAP, okay, CAP, this is CQB and this is CAP, and we need to prove them similar. Looking at the figure, to prove any two triangles similar, children, two minimum angles are needed to be equal. So here when we look at the figure, we can easily say which angles are equal. Angle P is equal to angle Q. Clear? Which other angle is equal? I have drawn them separately, but if I pick up this triangle and keep on it, what would happen? This C angle will exactly overlap angle C. It will cover this angle. That means angle C is equal to angle C. I can easily say. So what is that C? C is a common angle. So I can write here in triangle. So hence proved it is. So in triangle CQB and triangle CPA, which angle is a common angle? Angle C is equal to angle C, and reason is common angle. Clear? And angle Q is equal to angle P. Angle Q is equal to angle P, which is equal to 90 degree. Reason is given because they are perpendicular. Given? Yes or no? Because they are perpendicular. You can mention here that AP is perpendicular to BC and BQ is perpendicular to AC, and therefore you wrote it 90 degree here. So once you got these two angles equal, we can easily say that triangle CQB is similar to triangle angle C is equal to angle C, corresponding angle should be written in the line. Then after that Q is there, and Q is equal to what? P, so here will also come P. CQB, then CPB, and then here A, by which test? Angle test. So we are done with this. It is mentioned that if AP is 7 and BQ is 8 and BC is 12, then we need to find out AC. Okay, how do I do it? I proved two triangles similar. I have proved that these two triangles are similar. Okay. Once I prove two triangles similar, I must take corresponding sides. CQ upon CP is equal to QB upon PA, which is equal to CB upon CA, and the reason is corresponding sides of similar triangle. If two triangles are similar, corresponding sides will be equal. So now you just place the value. AP is 7. So in place of AP you will write 7. Let us write the value here. CQ is not given. Whatever is given, I will place the value. Okay. Here CQ is not given. CP is not given. QB is given. This 8. So CQ upon CP, which is equal to QB. QB is how much? 8. 8 upon PA. PA is how much? 7, which is equal to CB. CB, BC. CB and BC same. 12 upon CA. CA we want to find out. That is AC or CA. AC or CA is same. Now we can only take this 2 and we can find CA. See how. Now CA I will be taking here 8 upon 7. It is equal to 12 upon CA. CA will move in place of 8 and 8 will come in place of CA. So CA is equal to 12, 7 will go with 12, 12 into 7 upon 8 will come down 8, 4 2s are 8, 4 3s are 12, 3 7s are 21 upon 2, 3 7s are 21. Now we got 21 upon 2. So we need to divide 21 by 2. 21 divided by 2. 2 1s are 2 minus 0. 1 will come down. 2 zeros are 0. 1. Increase 0. Point. 2 5s are 10. 10.5. So when you divide it, you will get answer as 10.5. So AC is equal to how much? 10.5. Find AC, which is equal to 10.5. You can pause the video and you can solve the sum, children. Fifth sum. Here this is the trapezium. This figure is a trapezium. This two line PQ and SR are parallel in a trapezium. Opposite one pair of side will be parallel to one another. So we can see clearly PQ is parallel to SR, and PQ is parallel to SR given also, see, and AR is given 5 times, AR is given 5 times AP. Okay. So let me write it in a systematic way. AR upon AP is equal to 5 upon 1. Yes, just I shifted AP down. AR upon AP. AR is where? Here, and AP is here. Okay. This is AR. And this is AP. Okay. Right. Next, what is given? AS is equal to 5 times AQ. AS is equal to 5 times AQ. So I am going to shift down. I will be getting AS upon AQ, which is equal to 5 upon 1. AS. Where is AS? AS. This is AS. Okay, and where is AQ? This is AQ. So AS upon AQ is 5 upon 1. Both these ratios are equal to one another, you see. Yes or no? So let me write it here. I just wanted to know how it is and what it is. Systematically we will write the solution of the sum. So what is given first? AR is equal to 5 times AP. So AR is equal to 5 times AP. Let me shift AP down. AR upon AP is equal to 5 upon 1, and this is your first statement. Next, what is given? AS is equal to 5 times AQ. AS is equal to 5 times AQ. AQ will shift down. AS upon AQ is equal to 5 upon 1, and label it as 1 and this is as 2. If you go to see, children, the triangle which I have drawn here, red triangle, and a triangle which is light blue in color, this something is vertically opposite to one another. Yes or no? So here it is vertically opposite, we can say, this angle and this angle. So we can say that this angle is equal to this angle. So what is the name of this angle? PAQ. This is A here, children. A. So PAQ this is third one statement. Angle PAQ is equal to angle SAR, vertically opposite angle. Now we got two sides, corresponding sides. AR upon PA is equal to AS upon AQ, and in between those two corresponding side one angle is equal. So we can say that triangle PAQ is similar to triangle PAQ. Angle, if this side is parallel to this side, as it is a trapezium and it is also given PQ is parallel, so this angle will be equal to this angle, children. Corresponding angle, alternate angle, means if I draw this figure here like this, PQ, and this is R and this is S. So PQ is parallel to SR, so this angle is going to be equal to this angle, alternate angle. So angle P will be equal to angle R. So if here is P, I must begin with R this side, because P is equal to R. Okay, now next is A. So in this triangle A here, Q is equal to S, same way. Q will be equal to S, alternate angle. Clear? So therefore here it will be S. And these two triangles are similar by what? Side angle side test. Because of two corresponding sides are equal, and in between those two corresponding sides ratio one angle is equal. So the test of the similarity will be side angle side test. This will be the test of similarity. Now take the corresponding sides ratio. PA upon RA is equal to AQ upon AS is equal to PQ upon RS, and reason for this is corresponding sides of similar triangle. Now place the values. What we wanted to prove? We wanted to prove SR is equal to phi times PQ. We got SR here and PQ. We have got AS upon AQ. AS upon AQ as phi upon 1, and here we have AQ upon AS. So if AS upon AQ is phi upon 1, AQ upon AS will be equal to 1 upon phi. Invertendo. If we invert it, we will get 1 upon phi. So here I can write down AQ upon AS as 1 upon phi, which is equal to PQ upon RS. Now PQ will move, RS will go with 1 and PQ will go with phi. Phi will go with PQ. So RS so we will be getting here RS into 1 is RS is equal to phi PQ, and this is what we wanted to prove. RS is equal to phi times PQ, hence proved. Children, you can pause and you can solve the sum. Question number 6, you can see children here. ABCD is a trapezium. ABCD is a trapezium where AB, this is line AB, is parallel to CD. It is given also, and in a trapezium sides are parallel. In a trapezium, sides means one pair of side is, opposite side is parallel. So AB is parallel to CD. Let us write. AB is parallel to CD given, okay, and AC and BD intersect at point O. AB is given 20, AB is 20, CD is given 6, okay, and OB is given 15. We need to find out OD. Okay. So if I prove these two triangles similar, that is triangle BOA, I prove similar to triangle COD, then I can write the corresponding sides and I can place the values which are given and I can find the value. Okay, let us prove it. Now as AB is parallel to CD, can I say that this angle is equal to this angle, alternate angle? See, if I am drawing it here, see, CD, okay, this is C, this is D, and this is B, and this is A. It is a Z, children. So this angle is equal to this angle, okay, alternate angle. So I can say that angle D is equal to angle B. Angle D is equal to angle B. And one more Z you will get here, and that is again CD again C, D and A, B, but this time the transversal is CA, okay. So this angle will be equal to this angle, alternate angle. So we can write here angle C is equal to angle A. And reason both are alternate angle. when AB is parallel to CD. So both are alternate angle. Now this is enough for any two triangle to be similar, but one more angle we are getting equal. This angle is equal to this angle, vertically opposite angle. Let us write it. There is no harm in writing it. I can say it that angle COD is equal to angle AOB. See, if I want O, this angle O should come in the middle, so I write COD, and here O, this in this side, then write AOB. Okay, which angle? Vertically opposite angle. Since three angles are equal, 1, 2, 3 are equal to one another. Therefore, these two triangles are similar. I can write here. Therefore, triangle COD is similar to triangle. Now, I wrote here first C, but C is equal to what? A. So, here it is starting with C, so here it should start with A. And O, D is equal to what? D is equal to B. So B, corresponding angles we should write. The same fashion should be like this. You just cannot write anyhow. If you write anyhow, you will not be able to get the corresponding sides ratio in proper order, and then you won't be able to get the answer. So now you can say CO upon AO. Triangle COD is similar to triangle AOB by angle, angle, angle test. Now we will be writing the corresponding sides ratio. CO upon AO is equal to OD upon OB, which is equal to CD upon AB, and reason for this is corresponding sides of similar triangle. Corresponding sides of similar triangle. Now place the values. CO not given, write as it is. AO not given, write as it is. Now OD, OD you have to find out, upon OB, OB is 15, which is equal to CD is 6, AB, AB is 20. So we will be selecting this two, we will be taking this two. OD is equal to 15 will go with 6, 6 into 15 upon 20, 5 3s are 5 4s are 2 3s are 2 2s are. Okay, 3 3s are 9 upon 2. Now need to divide 9 by 2. So how to divide, children? 9, I know some children don't even know division. 2 4s are 8, 1 came down, 0 increased, 2 5s are 10, 0. So 4.5. So OD is equal to 4.5 unit. 4.5 unit. As the units are not given, you can write unit. You can pause and you can solve the video, children. Now question number 7th. ABCD is a parallelogram. Your parallelogram is A, B, C, D. Okay. And point E is on side BC. Yes. Point E is on side BC here. This is point E. Line DE intersect the BC at point E. No, line DE intersect line AB at point T. See, if you increase this line is, if increased, it is going up to here, and this line is going up to here and intersecting at point T. Clear? So, prove that DE into BE is equal to CE into TE. C into TE. Now DE into BE. Where is DE? Yes, this is DE. Into what? BE. This is equal to what? CE into TE. Now if I am tracing my hand for proving this DE, where is DE? This is DE. Okay. BE, where is BE? This is my BE. Okay. Then CE, where is CE? This is CE. And where is TE? This is TE. This is your TE. So when I want to write this line, I traced my line. Where I am tracing it on this triangle, small triangle, and on this big triangle, isn't it? So I need to prove these two triangles similar, and then I will be able to prove my. Children, ABCD is a parallelogram. AB is parallel to CD. Opposite sides of a parallelogram are parallel to one another. I will write here. AB is parallel to CD and AD is parallel to BC. Why? Opposite sides of parallelogram. Opposite sides of parallelogram. Okay, parallelogram. So if AB is parallel to CD, can I say AT is parallel to CD? I can say AT is parallel to CD because ABT are in one line. Yes, they are collinear. So I can also say AT is parallel to CD. And if AT is parallel to CD and TD is a transversal, TD is transversal. I'll show you now how. See. Coming or not Z? So we can draw this Z. Yes. So this is AT parallel to DC, and what is the transversal? This is your transversal. TD is your transversal. Transversal. So if this is transversal, you are getting a Z here? No? So this angle will be equal to this angle or not? Clear? So we can say this angle is equal to this angle. Okay, alternate angle. So angle ATD is equal to angle TDC, alternate angle. Okay. So this angle is equal to this angle. Fine. In this two triangle, we got this one pair of angle equal. One more pair we can get. Now say this. Vertically opposite angle. this angle is equal to this angle. So what is the name of this angle? BET. Angle BET is equal to angle DEC. E should come in the middle. Either you can start from DEC or you can say CED. Both will be right. These are which angle? Vertically opposite angle. So two angles are enough for proving any two triangles similar. So we can say, therefore we can say triangle. Let me write the name of this triangle. Triangle BTE similar to triangle EDC by angle test. Let us see whether I wrote corresponding angle properly or not. B T E BTE and T is equal to D. T is equal to D na. So T is equal to D and E is equal to BTE is equal to DEC. So there should be E here. See, BTE. So I can write here C. First I will write C because B is not equal to C given. T is equal to what? D. CD. Because T is there here, second angle. So second angle should be D. Because T is equal to D. CD. Yeah. T is equal to D. And E is equal to E. So E will come here. Vertically opposite angle E. Now they are equal, they are similar because of angle test. Now I will be writing the corresponding sides. BT upon CD. So BT upon CD is equal to TE upon DE, which is equal to BE upon CE, and reason is corresponding sides of similar triangle. Now what I want, DE, where is DE? Yes, here is DE, and this is DE. I wanted DE and BE. Yes, BE I am getting here, and I wanted TE. T is also there here. C I wanted. So these two ratios are enough for me to take. Now I will be taking these ratios here. TE upon DE, see, is equal to BE upon CE but what I want, BE into DE and T into C. See, T is already there, CE will go with this TE. So what you are getting, TE into CE is equal to BE is already there and this DE will go up and get multiplied and hence proved. So children, you can pause and you can solve the sum. In this figure, segment AC and segment BD intersect each other in point P. This is segment AC and segment BD BD are intersecting each other at what point? Point P. Clear? This is the point P. And AP upon CP is equal to given BP upon PD. Clear? See, AP upon CP is equal to BP upon PD. Then we have to prove that these two triangles are similar. Which triangle? ABP. ABP is similar to CDP. CDP. It is very simple and easy, children. See, it is already given. First we will start from given that AP upon CP is equal to BP upon DP, and the reason is given. First point. Second point, you can see this angle is equal to this angle, and these are which angle, children? These are vertically opposite angle. Therefore, angle, if I want to name this angle APB PB is equal to angle CPD, and reason is vertically opposite angle. Clear? Now if we compare these two, first statement and second statement, AP upon PC is equal to BP upon PD, and in between these two corresponding ratio one angle is equal. So we can say that triangle, third statement में triangle APB is equal to similar to triangle APB is similar to AP upon PC na CPD by side angle side test, because one side ratio is equal to other side ratio, and in between those two ratio one angle is equal. So side angle side ratio. And why did I write C here? See, APB is similar to triangle CPD, because AP correspond to PC. So what are we getting now? Corresponding side AP upon CP is equal to PB upon PD, which is equal to PB upon AP upon CP is equal to PB upon PD, then AB upon CD. What we want to prove? We only wanted to prove triangles are similar. That's all, it is done. But this is corresponding sides of similar triangle. As a practice you can write it. But up to here only you should write, hence proved that two triangles are similar. APB is similar to CDP. Now let us go for the next question. In the figure ABC, triangle ABC, point D is on the side BC. This is your triangle. Triangle ABC, and point D is on side BC in such a way that angle BAC AC means this big angle is equal to angle ADC. ADC, this small angle. Okay. Now children, you see here two triangles are there. I will draw them separately. When we draw them separately, then we understand better. Let me draw this triangle. A, B, C, ABC, and angle A, this is angle A here, okay, and ADC. Let us draw ADC. A, D, C. A, D, C. Now this is triangle ABAC and this is triangle ADC. What similarity you can find here? What is something same? By drawing this, by this looking at this sign, symbols, we come to the conclusion that angle A is equal to angle D given. Yes, and we can write that. First point, angle A is equal to angle D and reason is given. Second point, if I pick up this triangle and keep here as it is kept, what I am finding? This is completely overlapping it. See, that means angle C is equal to angle C and reason is common angle. Yes or no? So I can say that therefore triangle ABC is similar to triangle ABC similar to A. First is A na here children. First is A. So in other triangle to angle A, which angle is equal D? Therefore I should start from here D. D. Then B. I can write, okay, forget about second one. Third one. Third one, what is there? C angle. Angle C is equal to C. So I will write C. In the middle, what will come? I wrote D, I wrote C. In the middle, what will come? A. Clear? So triangle ABC is similar to triangle DAC by angle test. And now we can write corresponding sides test. Corresponding sides if I take corresponding side AB upon AD, AB upon DA is equal to BC upon AC, BC upon AC, which is equal to AC upon DC, AC upon DC, corresponding sides of similar triangle. Now what I want to prove? CA square. So here if I take this to ratio, if I am taking this to ratio, BC upon AC is equal to AC upon DC, and if I cross multiply them, if this multiplied together one another, what I am getting? BC into DC, BC into DC, C. DC will go with BC is equal to AC into AC. AC is already there into what? AC. So AC into AC will be what? AC square, which is equal to what? BC into DC. Hence proved, children. This is what we wanted to prove. See, either you say CA square or you say AC square is one and the same thing. So hence proved. You can pause and you can solve the sum, children. This completes with 1.3 exercise and 1.3 solved example. Children, like, share and subscribe. Thank you for watching. Practice more and more. And if you don't understand, rewind and solve the sum. If any doubt, please comment and let me know. Thank you, children.